Hello everyone and welcome. It's Hugh here at Loxone and I'm here again with another one of our focus series videos. So with this series, we look at particular topics or subjects that we can accomplish with Loxone and then how we accomplish them. Usually we look at a particular topic and then we have a specific function block that we can solve it with. With today, our scenario is a little bit more complex. So we're looking at a particular problem to solve, and that is irrigation. Now, irrigation can come in many forms. It could be watering your rose bed in your garden. It can be agricultural irrigation for things like polytunnels with fruit and veg growing. And it can also be irrigation of sports pitches. And so in my particular scenario today, we're going to look at irrigation of a sports field. So with football fields in particular, they have very, very specific requirements. You usually need to water them several times a week to a certain watering level. You also need to make sure that they're not overwatered. You need to make sure that they're watered prior to a match, and there's usually a little spritzing that goes on mid-match as well at half-time. So there's a few different parameters to look at. And so we have a customer that wants to automate, or at least automate as much as they can, their football pitch irrigation so that somebody doesn't have to go out and press a switch to do it for them. And so for our brief, we have an irrigation system that's got a single pump, and that single pump runs 12 sprinklers. Now, because that pump can't build up enough pressure, it can't run all of the sprinklers at the same time. It can only run one sprinkler at a time. And this is actually very, very common. Even in like Premier League level football pitch irrigation systems, the pumps that they run physically cannot create a high enough pressure to run all of the sprinkler sets. And so that's why if you ever look at half time, you'll see that the sprinklers run in sequence around the pitch. This exact reason. So we've got a single pump with 12 sprinklers, only one sprinkler can run at once. We've also got a drain valve that should run after the sprinkler sequence runs to make sure that if there's any excess water in the pipes that it's drained off. That's because if water gets left in the pipes and then it's freezing cold overnight, water will expand because it's freezing and it could burst the pipes. Whoever's managing this should be able to adjust the runtime of the irrigation. And the reason for that is that a football pitch, I believe it needs to have the equivalent of 1 week's worth of water twice a week to maintain a healthy pitch level. Now, the amount of irrigation that you're going to have to do is going to be determined on the pumps, the amount of the size of the sprinklers, and how much physical water they can push through them. And that's usually worked out by the manufacturer. The manufacturer of the pump set and the irrigation system will usually say you have to irrigate for 20 minutes twice a week to hit your 2 weeks worth of water per week. And so we want whoever's managing this to be able to set a run time. The cycle obviously shouldn't run if it's raining. If it's due to rain within the next, say, 4 hours, or it has rained within, say, the last 12 hours, because then you'd be overwatering the pitch. The irrigation should always finish at dawn. So the automatic version of the irrigation finishes at dawn, and that's because it's always better to water anything before the sun comes out, because the sun will come out otherwise, and it'll be a magnifying glass, the water droplets, and it could damage whatever you've been irrigating. But also, we need for this irrigation to be manually run as well. So at halftime, when all the players go in down the tunnel, whoever's looking after this can press a button in an app or a web page and it can start a manual irrigation. So let's get started. So the first thing I'm going to do is I am going to swap my camera over to my demo case, because a lovely thing that I'm going to be able to do is assign these relays here as some of those sprinklers and then actually run this when I've configured it. And then I am going to make sure that I am in config. So here I have a blank config file just with a few. Now, what I always find is when I have complex scenarios to solve with config, I usually find that I have a two-staged approach to fixing and solving them. The first stage is I usually start at the end and work backwards, because I usually find that that is a more logical way of breaking through this problem, is to start right at the end and work my way backwards. I also like to separate what I'm doing into chunks. Because if I just take that entire scenario on its own, that's a big old frog that I've got to eat. Whereas if I can cut that frog up into pieces, I can make it much more manageable. And that's a reference to a book called Eat That Frog, if anyone was wondering. And so I'm going to start at the end. And my end result is that I have 12 sprinkler valves that I need to run, a drain valve and a pump. So I have 14 relays. So the first thing that I'm going to do is have 14 relays out on my page. So I've got 8 relays in the demo case. And by the way, something really cool you can do in config. It's one of Hugh's top tips. Just going to name the first relay as pump. And the rest of these relays are going to be sprinklers. And Hugh's top tip of today, if you highlight multiple inputs or outputs, and then on the name, you start naming them, and you put the number 1 or the number you want to start with and press enter, it sequentially numbers them from that point. So really, really cool little top trick. So if that was sprinkler 7, sprinkler 8, 9, 10, 11, 12, and again, sprinkler, and this time start from 8, and look at that, it sequentially numbers them from that point. And then finally, we've got the drain valve. And so I'm going to take all of those out onto my page, all of those relays. Now the next bit is, in that scenario, I said that the pump wasn't man enough to run all of the sprinklers at the same time. It could only run one at a time. Now, for anyone that's been watching this series from the start, we've actually already looked at a scenario where we have something that has different modes and only one mode can be active at any one time, and there's a function block specifically for that. And that's a radio button. So with a radio button, I can take it out. I can, if I want to, name these outputs. Just for the sake of quickness, I'm just going to give these a number name. Drain valve. There we go. I'm not going to name an output for the pump, and I'll show you why in a second. So I've got outputs 1 through 12 as my sprinklers, and output 13 is the drain valve. So I'm just going to whack all of these on now as well. So sprinkler 1, oh no, that's sprinkler 3, sprinkler 3, sprinkler 1, 2, 4, 5, so on and so forth. So all of my sprinklers are on the correct outputs. I can always press auto position at any point, just make it look neater on the page. So 8, 9, and this is where I wish I'd done a scenario with less sprinklers. There we go. So there is our 12 sprinklers, and then output 13 is going to be our drain valve. Now the reason I haven't created an output for the pump is because I want the pump to run when any of these outputs are running. And so what I'm actually going to do is I'm going to use the output AQ, which is an analog output to indicate currently active output. This is a relay, so it's digital, but that doesn't matter because any value above 0 will turn this on. So my pump can go to AQ. However, again, thinking ahead, I probably want the first sprinkler to be able to open before the pump fires. So I probably want to add a little bit of a delay to this before I fire the pump. And so that would be the start of our journey. Only one sprinkler on at the time, the pump on whenever any of the sprinklers are on. The next thing I have to do is just clean up this radio button a little bit. So first thing is, I don't want to see this in the app. But this logic should have behind the scenes. On a radio button, you can also set the maximum number of outputs that are on the radio button. You can also this here, and that means that on a scroll, it then doesn't scroll to all off, and I'll show you why we're going to be doing that in a second. So we've started with our radio button. And as I said, we're going to sequentially build up this config as well. So let's get started with this irrigation being started. Now we've said that it has to run for a specific amount of time. So we need a function block that we can trigger that then has an adjustable delay before it turns back off again. And again, for anyone that's been watching the series as a whole, we have a function block for that. For me, stairwell light switch. Great function block for this. And on our radio button, we have an input for plus. Single pulse triggers next output. I, however, can't just straight away stick that to there, because what will happen is when that goes off, it'll do output 1, but it won't do anything else. So what we need to do is we need to turn that output of the light switch into an output that changes and pulses on plus every so often to switch between the sprinklers. And so again, great function block for that. Pulse generator. So a pulse generator creates a pulse at the output with an adjustable on-off duration. And so I need to invert the input of the pulse generator because I want it to be activated by the stairwell light switch. And then what I need to do, and this is where we get a bit funky, I want to make sure that for however long this light switch stays on for, every sprinkler gets an even runtime. So to do this, first of all, I don't care about those two. I only care about the runtime, the TH duration of the stairwell light switch. The pulse generator is going to do an on pulse for 1 second. So it's the off pulse that I want to change. So in between every on pulse, how long it stays off for. So I need something to work out what the off duration is. So what I really need is I need to do a formula. There we go. So we've got a formula function block. And so I need a formula into TL. Formula function block is great. If I double click, I can type in a formula. So what I need is I need the runtime, which the stairwell light switch currently is set to 180. So that would be my runtime. But then I need to add on however long I've set the switch on delay of the pump to run, just so it runs for those extra few seconds. Then I need to take away the number of outputs I'm going to be running. So I'm going to be running 12 sprinklers, so I need to take 12 off it. And what this will leave me with is that will leave me with a number that is the runtime minus the number of on seconds, because for every second that it's on, I need to take away from the off time. And so because it's outputting for 1 second for every sprinkler running, that's why I need to minus 12 from total runtime. And then once I've got that figure, that's my total runtime. I then need to divide that by the number of sprinklers I'm running. And okay that. And so that is then my pulse generator done and into plus. Just move that out of the way slightly. And so if I then simulate that, so start simulation, what you'll see, stairwell light switch, 180 seconds on. And so what we've got is 14.4 seconds for every sprinkler. And if I just grab my calculator out and do 14.4 times 12 for the 12 sprinklers, that's 172 seconds. Plus the 12 seconds for the pulse generator. And as you can see, pretty much bang on the length of time that we're going to be running for, because I said I added an extra 5 seconds on there anyway. Boom. So that would be then stage 1 of our scenario sorted of every sprinkler running from an equal amount of time for that stairwell light switch. The next stage I want to do is I want my radio button to be turned off when this switch goes back off. So at the moment, if I just stick an input into this stairwell light switch, just to simulate this for you, start simulation, wash that. You can see at the moment, sprinkler 1 is running. 5 seconds later, the pump will start running. And then after 14.4 seconds, it will move to sprinkler 2, so on and so forth. I'll just let it move to sprinkler 2 so you can see that. So you can see I'm not lying. There we go. We're now on to sprinkler 2. I need it to end when this stairwell light switch turns off. So to do that, the next bit I'm going to do, again, if you watch these videos, you'll have seen me use edge detection loads of time. I'm going to take the output from the stairwell light switch into an edge detection block, and then the off pulse, so the falling edge of the edge detection, is going to reset my radio button. So that would turn the radio button off when this reaches its endpoint. Fantastic. Stage 3 is we said this actually wanted to have an adjustable runtime. So at the moment, we're bound to the runtime that's set here in the parameter of the stairwell light switch. I mean, the great thing about config though, is that parameters can also be used as inputs. So if I just move all this down slightly, that parameter for runtime is actually an input. What I can do with this then is I could actually create something that's displayed in the app that the customer can see and can adjust how long they want this irrigation to run. Something like a virtual input. So I could create a virtual input and I could call this irrigation runtime, and in brackets just put minutes. So they know that this would be how many minutes they want it to run for. It's going to be analog, and I don't want them to be able to set half minutes because that just doesn't make sense. Now, I couldn't just go and put that straight into TH, because TH is an input for seconds. This, the customer is going to be setting in minutes. So we need to turn minutes to seconds. Really easy. All we need to do is take whatever the customer sets in the irrigation runtime and then multiply it by 60. And that will turn minutes into seconds. Stick that in TH. Again, show you in simulation. So now if I set 30 minutes here, 30 times 60 is 1800. And so now it's putting a value of 1800 seconds that this must run for. Boom. So now, if we've got this running for that amount of time, the next thing we need is we need to then adjust this formula as well. Because at the moment, we're setting how long this stairwell light switch runs for, but these sprinklers are still only going to run for 180 seconds. So what we do as well is we take this same multiplication and we put it into our formula block. And now in the formula block, instead of using a fixed value of 180, we actually put I1. And that means that it'll now actually be taking the value that we have here into this formula. And so to then, again, show you that. So if I set a value of 30, look at that. So now each sprinkler will run for 149 seconds. And there's stage 3. That's our adjustable runtime, because this virtual input we can see in the app. We could even, if we wanted to, give it a pretty picture. Let's rename our stairwell light switch as well to irrigation control. And again, we can give this a nice pretty picture. Plant watering. This as well should probably go under the same category of controls. And so that's our adjustable runtime sorted. So if we look back to our scenario, single pump, done. 12 sprinklers, only one running at a time, done. Drain valve, I'll come on to that in a little bit. Adjustable runtime, done. So next, cycle not running if it's raining. So let's think about that then. So firstly, we have if it's currently raining. So don't run if currently raining. How do we do that? Probably we want something like a weather station, because a weather station has a rain input. So we can take that rain input. But if we look back at this, we want to say doesn't run if it's raining or has rained within the last 12 hours. So why don't we just take that rain input and just hold it for 12 hours? So if it rains, it holds that output for 12 hours. So we could take a switch off delay and we could put 12 hours in here. 12 hours in seconds is 43,200 seconds. And then that could go onto the reset of our stairwell light switch. So now, if it's raining or has rained within the last 12 hours, this switch can't run. So there is us stopping it due to rain. The next bit of this was if it's due to rain in the next 4 hours. So now that we've got a weather station, that means that we also get a 10-year subscription to the weather service. So if we look up here at weather server, we don't appear to have a value for rain. What we do have though is precipitation. And precipitation is measured in litres per metre squared per hour. Now, whenever you've seen the weather reports on the BBC or wherever, and you see that they say there's going to be 5 millimetres of rain, 5 millimetres of rain is equal to 5 litres per metre squared of rain. So if they're saying there will be 2 millimetres falling over the next hour, they mean 2 litres per metre squared per hour. And so if you actually look at what constitutes rain, then anywhere from 0.5 millimetre to 4 millimetres per hour is considered moderate rain. So between 0.5 litre to 4 litres per metre squared per hour. So we could say somewhere in the middle of, let's say, 2 litres per metre squared per hour equals an adequate amount of rain that we don't want to run this irrigation. But we have a problem. This value here, this input, is only current weather. We've already got that. We've got a rain input. But, and this is really cool about the weather service, we have the ability to set offsets. So what I could do is I could actually create some new weather data and say what my data type is and what my offset is. Now, I can't just go straight for +4 hours because that means in exactly 4 hours time. It doesn't mean every period of time between now and 4 hours. So if I want to see every period of time between now and 4 hours, I'd actually need to have 4 of these. And again, with the names, I can say precipitation, it's a difficult word to spell, +1, press enter, and it'll sequentially name them. I can say that the data type for all of them is precipitation, and then I could go through them one by one to say that this one is going to be +1, +2, +3, and +4 hours. And so then, those are my 4 values for precipitation over the next 4 hours. I could add all of those together. So all 4 of those being added together. And then if the output here is equal or greater than what we've said constitutes enough rain, which is 2 litres per metre squared per hour, then, again, we turn the irrigation off. We reset it. And that then would be all of our scenario for the cycle not running if it's raining. That, for me, is stage 4. Stage 5 is where things get really tricky because at stage 5, I've said I always want the irrigation to finish at dawn. So this is where it gets really tricky. So what we have to do, if you take a look on config at times, we've got loads in here. And one of these times is actually time of dawn. And time of dawn is measured in minutes since midnight. So if we take time of dawn out, which is measured in minutes since midnight, then we've actually already got another input in here, which is minutes past midnight. So we've got time of dawn in minutes past midnight and the current minutes past midnight. So why don't we take time of dawn and why don't we subtract our runtime? So over here where we have our virtual input for runtime in minutes, why don't we subtract the runtime from time of dawn in minutes past midnight, and then if this value here equals minutes past midnight, we trigger our irrigation. So time of dawn in minutes past midnight minus our amount of time for irrigation, and if that value equals minutes past midnight, then we run that stairwell light switch. And that then ensures that our irrigation would finish at dawn. And so that's stage 5. And then the last little bit I said is I wanted to have a way so that I said I would figure out the bit with the formula with the drain valve at the end of it, because at the moment my formula only takes into account sprinkler 1 through 12, but it doesn't have any account for the drain valve. So at the moment my config would end at sprinkler 12 and then the drain valve wouldn't run. The reason that I've omitted it until this point is because I want to make sure that even if somebody goes in the app and manually presses stop on this stairwell light switch, that the drain valve will still run. And so what I want to do is actually, instead of this edge detection here for the falling edge of the light switch, turning this straight off, I actually want to say that the falling edge of the stairwell light switch, actually, what I want to do with it is I want that to then go into a switch off delay. So I take this, so take the falling edge of the stairwell light switch into a switch off delay that will hold that on for 30 seconds. And then I'm going to use another edge detection. And that then the rising edge of the switch off delay goes straight to output 13, which is our drain valve, and the pump will be running anyway. And that then the falling edge of the switch off delay, that's then our reset. And so that ensures that even if we manually stop the irrigation cycle with the stairwell light switch, the drain valve and the pump will still run just to drain any water out of the system. And that is me done. I'm now going to connect into my demo case and save this in and show you it running. And I know that this is quite a complex bit of logic, so I will do one last time where I run through it with you. But if I head back over, I've done it again, left my emails open. If I head back over to the web interface and show you it in here, look at this. We've got our pitch irrigation. This is our stairwell light switch, and this is our irrigation runtime. So if I set this irrigation runtime for, let's say, let's just go for 5 minutes. So irrigation runtime of 5 minutes, and let's now manually start it. So switch on, and then I'm going to stop my share as well so that you're full screen on my demo case. Look at this. Sprinkler 1 and the pump is on, and then after however long 5 minutes is, minus 12 divided by 12, the pump will stay on, but we'll move on to the second sprinkler. I think it'll be around 20 seconds if my head maths is good. So in around 20 seconds, obviously my head maths isn't good. There we go. We're on to the next sprinkler, but the pump's still running. And there is our sequential water irrigation system done. If there was rain, this would stop, but it would still run the drain valve and it would run the pump. If there was due to rain, it wouldn't be running at all. And for however long I adjust that slider for, it will also adjust the total runtime. And as you can see, each sprinkler running for an equal amount of time, done. Back to sharing my screen. Just to show you, it's currently on. If I now open up my config file, and I just go in live view here for you, you can see we're currently on sprinkler 3 with the pump running. I've just moved on to sprinkler 4, and let me finish up with just manually, if I can just squidge these into one box for me. If I just switch off this system, watch what happens. So switch off. Oh, and I think I've just been disconnected from live view. No, it was my own mistake. Somehow my reference ended up in the wrong place. Yeah, somehow my reference ended up in the wrong place, which is why it didn't recognize that. So you saw the falling edge worked. The rising edge didn't work because somehow I ended up with a reference in the wrong place because I wasn't paying enough attention. So let's just double make sure that should go to input 13 and save that in. And then I'll give it one more try. But while that's saving in, just to reiterate, working backwards, here is our 12 valves, our 12 sprinklers plus a drain valve plus our pump going into a radio button. The radio button, because that only allows one output to be active at a time. The pump is on the AQ output so that regardless of which of these is on, the pump will also be running. The pump, however, has a slight delay before it starts to ensure that the sprinkler has time to open. The radio button is set for a maximum of 13 outputs, so it can't go to output 14 by accident. It also skips the all off mode because we are manually turning it off ourselves. We then have a stairwell light switch that goes into a pulse generator. The times of the pulse generator are dictated by a formula that works out our total runtime that we've set via a slider to make sure that an equal amount of runtime happens for each sprinkler valve. This pulse generator then pulses between the different outputs of our radio button. We're using the TH parameter on the stairwell light switch to determine the runtime. And so what we're doing is we're taking a virtual input, which is a slider in the app. We're multiplying that by 60 to set our runtime and also into our formula for how long it should run. We then have our rain input into a switch off delay that holds it for 12 hours, which turns this light switch off, this stairwell light switch off to make sure that it can't rain if it's rained within the last 12 hours. We're then also taking forecasted precipitation over the next 4 hours, and if it is greater than 2 litres per metre squared per hour, again, it doesn't allow it to run. And then the final bits and pieces is when this stairwell light switch turns off, the falling edge pulses a switch off delay, which holds for 30 seconds. And the rising edge of that switch off delay activates our drain valve and pump. And then our falling edge of that switch off delay turns all of it back off again. And so to show you it all working, here's it currently running. You can see sprinkler 1 starts, 5 seconds later the pump comes on, and so that is our sequence running. If, however, I manually stop it, so switch off, there we go. Now the drain valve is running and the pump is running, and after 30 seconds they will both turn off. And there we have, and I know it looks quite complex, the config file that I'm going to upload along with this video is going to have notes on it as well, so you'll be able to see the different stages. But actually, when you break it down, it's a fairly straightforward piece of config. And then the last thing we could do is, let's say we only wanted this to run twice a week. It's dead simple. We would add in a schedule block. We would add the 2 days of the week that we'd want that schedule to run, but we would require activation. And then this stairwell light switch would actually be the trigger for the schedule block instead. And there we have an irrigation system with Loxone. And this is fully scalable as well. Doesn't matter how many sprinklers you have, how many pumps you have, whether you're watering your rose bush or whether you're doing a Premier League football club, you could scale this up and down exactly as required. So let me just finish with the camera back on me. Thank you all very much for joining. I hope you've enjoyed, and please join me again next time. Goodbye, everyone.